So reporting category 7 is our last reporting category, and it is on properties of exponential and logarithmic functions. So the first vocabulary word we have is a logarithm, and we're going to write y equals log base b of x. That's read log base b of x. It's another way of writing an exponential function because y equals log base b of x is the same thing as b to the y equals x. Exponential, we use the exponential parent function of y equals 2 to the x. Exponential and logarithm, those are inverses of each other. The product property says that log a plus log b equals log a times b. That's the product property for logs. Log a plus log b equals log of a times b. The quotient property says log a minus log b equals log a divided by b. Power property says that if we have log of a squared, that equals 2 log a. Or vice versa, 2 log a equals log of a squared. Change of base says if we have log base b of a, that equals log a over log b, so that you can put it in your calculator to solve it. Those are our log properties. So our first question says, given y equals a log x plus c plus d, what would happen to the graph if you change the value of c? So that was left off your paper. It should be the value of c. So if we look at this formula, that c that's inside the parentheses, what does that do to the parent function? What does that do to the graph? Inside the parentheses moves the graph to the left or to the right. It doesn't stretch it or shrink it, so A doesn't work. A says that it's a vertical stretch or shrink. It's not a stretch or shrink, it's just a move left or right. B says the same thing about stretch and shrink, but horizontally. It's not a stretch or shrink at all. It is a horizontal move, so that means that it has to be answer D. A positive C value moves it to the left, a negative C value moves it to the right. So inside parentheses like that is a left and right movement. Number 2, the solution set for the equation, and the equation is log base 4 of x squared minus 6x equals 2 and then it's a multiple choice problem. So we have to solve this. So if it's a log problem, to solve it, I'm going to rewrite it as an exponential problem. So I'm going to write it as an exponential problem starting with the base. Our base is 4, and then I go to the 2, so 4 squared equals x squared minus 6x. Then it's a quadratic problem, so I'm going to write it as x squared minus 6x minus 16. Okay, so where did I suddenly get 16 from? 16 came from this 4 squared 16, and then I moved it to the other side. And now I'm going to factor this. Two numbers that multiply to negative 16 and add up to negative 6 would be x minus 8, x plus 2 equals 0, so x equals 8 and x equals negative 2. But what we need to do is make sure that when we plug that in, it comes out to be a positive because we can't find the log of a negative number. So I'm going to take that 8 and plug it in to that x squared minus 6x. So 8 squared minus 6 times 8 comes out to be 16, so that's a positive, so that's okay. And then the negative 2 negative 2 squared minus 6 times negative 2 comes out to be 16 again. So that's okay. It's fine to have both of those because they both make that be a positive. So the answer would have to be D. Number 3, which of these equations is the exponential form? And that is log base 5 of 1 over 125 equals negative 3. And we want the exponential form. For exponential form, you write down what the base is first. So this is log base 5 to the negative third equals 1 over 125. And that's your answer. So it's choice B. Number 4, which of the following does not equal log base 6 of 42? That's what that says right there, log base 6 of 42. I know it's kind of pixelated and it's hard to see, but that's log base 6 of 42. So what I have to do is look at my answer choices. A says log base 6 of 6 plus log base 6 of 7. When we're adding with logs, what do we really do with the 6 and the 7? We multiply them so that that equals log base 6 of 42. So is A our answer? No, because we want the one that does not belong. B says log base 6 of 84 minus log base 6 of 2. When we're subtracting, what do we do with those two? We divide. 84 divided by 2 is 42. So is B our answer? No, because we want the one that does not equal. If we look at C, C uses the change of base formula. Change of base is log 42 over log of the base, so log 6. So C is not it because C is set up correctly. Has to be answer D. D is the one that does not work. Number 5, which of the following situations would best be modeled by an exponential function? That exponential is left off your paper. So take a minute and pause the video and read through those 4 answer choices. So answer A, the amount of money in a bank account that initially has $1,000 and $40 is deposited each month. That is a linear function because the exact same thing is done every single month. $40 is deposited in every single month. It's the exact same. When it's the exact same like that, that's linear. If we read B, the amount of money in a bank account that initially has $1,000 and $40 is withdrawn each month, that is still linear because it is the exact same amount that's happening every month. Every month they're taking $40 out. That is a linear function. C, the amount of money in a bank account that initially has $1,000 and 20% of the balance is withdrawn each month. So what that means is they take out 20% of $1,000 the first month. The next month they take out 20% of what's left in there, then 20% of what's left, 20% of what's left. It's not the same amount every time because the amount that's left in the account is different. So that is the sign that that is an exponential function. And if we look at D, just to make sure that we know what it's saying the amount of money in a bank account that initially has $1,000 and 20% of the owner's monthly salary is deposited each month. That's the same amount every single month. 20% of the salary is the same. So nothing's changing there. In order for it to be exponential, it has to be different each month or each year, each whatever that amount of time is.